Academician Maxine is a prominent biochemist and fierce science advocate who elucidated the genetic code and transposon. She was born in New York City in 1931 and passed away in July 2024 at the age of 93. She received a bachelor's degree in chemistry from Swarthmore College. At that time, it is a very brave choice because a female scientist at that time is quite few. After earning a PhD in biochemistry in Yale University, she joined the field of nucleic acid biochemistry. In 1956, she began postdoctoral training at the National Institute of Health in the United States using polynucleotide phosphorylase to synthesize RNAs. Marshall Lierenberg soon achieved in vitro translation of her polyuridine sample into polyphenylalanine. And the findings spurred a 5-year multi-laboratory race to complete the 64-word genetic code. In 1975, at the National Cancer Institute, Singer's research interest turned to the repetitive DNAs that makes up the majority of human genome, in particularly the L1 family of long interspersed nuclear elements. In 1987, Singer's group identified an element family in a cancer cell line indicative of transposition activity. She collaborated with Dr. Haik Khazajian, exploring the impact of active transposable element on human and their genomes. Besides her scientific research, Singer was influential in refining science policy. Leveraging her prominence in the field, she co-organized the famous Asiloma meeting to address the public views about recombinant DNA technology in 1975. The meeting allows for open debate on potential hazards of recombinant DNA to public health and environment, evaluate the safety requirement for experiment, and helped frame federal research guidelines. As the president of the Carnegie Institution of Washington from 1988 until her retirement in 2002, Singer was a spokesperson for curiosity-driven science. She excelled in identifying exceptional individuals and providing them with freedom, resources, and trust. In 2006, Commentary in Science, Singer asserted that schools and universities must find ways to encourage and ease the pace for women who are inspired by the great scientific adventure. She established a science program for inner city children and another to improve science instruction in Washington, D.C. public school. These programs inspire a love of science in countless students and teachers. Singer's contribution to advancing science and science policy were acknowledged by her election to the National Academy of Science in the United States and the Academician in our Academy. Her awards include National Medal of Science in 1992, U.S. NAS Science of Public Welfare Medal in 2007, and Public Service Award of the American Society for Cell Biology in 2008. Singer upheld the principles that scientific advances are driven by individuals free to explore their own ideas, that all qualified individuals should be able to pursue research careers, and that scientists bear responsibility for communicating their findings and remaining accountable to the public. She championed the importance of public understanding of scientific discovery and established programs to get children excited about science and support science teachers. Singer models how to value fundamental discovery, fact-based science education, and equal access in the scientific enterprise, and she showed scientists how to speak up and prioritize inclusion. In a 1991 Science editorial, Singer contrasts role model with heroes, describing that a hero known for courage and nobility of purpose, thereby uplifting our own ambitions out of narrow, self-centered concern. In all respects, Academician Singer was a hero.